guys, Professor Calculus is here, and today in this video we're gonna solve this integral once again, but with a shorter method and using Feynman's trick. So as usual, in the previous video, I'm gonna go ahead and define a parameter t that is e to the negative tx sine x over x dx, and if I find I of 0, I have found my integral, which is sine x over x dx. Now, I'm going to go ahead and differentiate it. And when I'm taking total derivative of an integral, which is from 0 to infinity of e to the negative tx sine x over x dx, this is going to move inside I prime of t, and I'm gonna get a partial derivative, and if I partially differentiate it, it's gonna become negative e to the negative tx sine x over x dx. Now let's use the Euler's formula here. E to the ix remind us that it is equal to cosine x plus I sine x, and the imaginary part of e to the ix is sine x, so I can replace it. So this is gonna go away. Sorry, this x should have gone away. So this sine x is actually the imaginary part, so I prime of t is actually negative the integral from 0 to infinity of e to the negative tx imaginary part of e to the ix dx. And if I write it again here, it's gonna be negative the integral from 0 to infinity of, sorry, I forgot the imaginary part, negative the imaginary part from 0 to infinity of e to the negative tx times e to the ix dx. And my I prime of t is going to be negative the imaginary part of this integral e to the ix minus tx dx, and factoring it out, it would give me e to the negative x times x minus I dx. Sorry, t minus I. So I'm gonna here go and say u equals to x times t minus I, du is dx times t minus I, dx is du over t minus I. And if I substitute all of this here, my I prime of t is going to be negative the imaginary part of the integral from 0 to infinity, and that is going to be e to the negative u du over t minus I. And I can, so this integral here is going to go down to 1. So negative imaginary part of 1 over t minus I, the integral from 0 to infinity e to the negative u du. This is going to go down to 1, and I prime of t is just the negative imaginary part of 1 over t minus I. How do we find the imaginary part of it? So we're gonna, to find the imaginary part, I'm gonna multiply and divide by t plus I, t minus I, t plus I, and it's gonna be negative the imaginary part of t plus I, t squared minus I squared, which is negative imaginary part of t plus I over t squared plus 1, and the imaginary part of it is just I over t squared plus 1, which is negative 1 over t squared plus 1. And integrating this is the derivative of negative arctan of x, thus I of t is negative arctan of t plus c. And to find this constant of integration, I'm gonna let t be equal to infinity, approach infinity, and I of infinity is actually the integral from 0 to infinity of e to the negative infinity sine x over x dx, which is going to go down to 0, and arctan of infinity is pi over 2, so c minus arctan of infinity is 0, c minus pi over 2 is 0, thus c is pi over 2, thus I of t is negative arctan of t plus pi over 2, and I of 0 is pi over 2 because arctan of t is 0. Thus, the integral from 0 to infinity of sine x over x from 0 to infinity is pi over 2. Thank you for watching this video. Please like and subscribe, as it is free. You can always change your mind later. And I'll see you next video.